Okay guys, in this video we are actually going to run a hypothesis test all the way through with all 5 steps. And so once again, this is coming from the guided notes on sections 10.1, 10.2, and 10.4. You want to make sure you have your calculator. You want to make sure you have your formula sheet, in particular your normal distribution table, and of course, again, the guided notes. Okay, in this example, it says we want to find evidence against the claim that 35% of Wayne State students applied to a different institution. We think more students applied elsewhere. We take a random sample of 2,275 Wayne State students and find that 853 applied elsewhere. So giving us a statistic of p hat is 0.3749, which we round to 0.375. So can we conclude from our findings that more students applied elsewhere? We're going to use alpha is 0.05. So first thing to notice, one of the things when we look at exams, for example, somebody says, well, how do I know I have to do a hypothesis test? Usually the big giveaway is they're giving us a level of alpha, okay? And then they're also asking if we can conclude from findings that something happens, or maybe we want to test a claim, but usually the giveaway is the alpha level. So that suggests to us that we have to deal with a hypothesis test. Now, what we'll see in subsequent sections is we've got other types of hypotheses tests, and we've got to be able to tell the difference, and we'll talk about that as we go. Okay, so first things first, step 1 is to build the hypotheses, okay? And so in this case, we have to think about what exactly is this dealing with. Is it dealing with means or proportions? Now, it was a dead giveaway because they told us about p hat, right? And so this is going to be surrounding p. Okay, now the question is, which number do we use? Do we use 0.375 in the hypotheses, or do we use the other value that they gave us of 35%? Well, you have to remember that the hypotheses are always statements made about the population, and so very clear that 0.375 is coming from p hat. That is the sample, so that cannot be the number that we list there, so it has to be 0.35. Now the question is, what inequality do we use? Okay, and so what we have to ask then ourselves is, well, what exactly are we being asked to find? Okay, so it says, can we conclude from our findings that more students applied elsewhere? And so what that means is we think that more students applied elsewhere. So in other words, that proportion is more than 0.35. So Wayne State is saying, or somebody is saying that we want to find evidence against the claim that 35% of Wayne State students applied to a different institution. We think it's more, right? We think more students applied elsewhere. So that means that the null has to be less than or equal to. Okay, so that's the good news. Step 1 is done. Okay, now for step 2, remember, is the test statistic. Okay, and that fancy name for the test statistic is the z-score. So we have to figure out the z-score. Okay, so this means that we want a probability that p hat is what? Well, remember that this inequality, this probability, always takes the form of the alternative. So it's always going to be greater in this case. Okay, so that alternative is greater. That means the probability has to be greater. And notice the variable that I'm using here is p hat. I want the probability that the sample proportion, well, what's the number for the sample proportion? Well, we took a sample and we had it was 0.375, right? And so this is what I have to find the probability of. Okay, now from here, hopefully this is pretty easy for you because, again, this is coming from chapter 7, right, when we dealt with the central limit theorem. Okay, so this is going to give us what? This is going to give us the probability that z is greater than, and then we've got this big fraction, and we've got the square root down here. Okay, so this should be what? 0.35 times 1 minus 0.35, all divided by, and n in this case is the 2,275 students. And in the numerator, it's going to be p hat, which was 0.375, minus p, which is 0.35. Now, again, want to draw emphasis that in that denominator, in that crazy square root, we're always using the value of the parameter, right? The 0.35, not the 0.375. Big mistake people make is they use 0.375 in the square root, okay? They can't use the value for the statistic because we know about the parameter only. So we have to use the information on the parameter. It gives us more accurate result. Okay, so I'll give you a second to compute it. Maybe you can pause the video and see, but I can tell you if you pause it, the answer should be z greater than, and let's see what I had, 2.5. So hopefully you have something close. Okay, so that being the test statistic, now what I need to do is I need to get the p-value. Okay, so test statistic here is the 2.5. Okay, so the next thing we have to do is we have to get the p-value. Now clearly, this being greater than, remember that is an area to the right. So 2.5 is somewhere here. So you've got a couple of ways to get area to the right. Again, you can look up negative 2.5, which would be by symmetry, or you could look up the 2.5 and get the value. Either way, the p-value that we're going to get is 0.0062. Okay. Now, step 4 is we have to compare that p-value, okay, versus the level of alpha. And so the p-value here is 0.0062. And the level of alpha is 0.05, okay? And so which one is bigger? Okay, well, very clear that the p-value is less than alpha, so alpha is obviously much bigger than 0.0062. So what we say is this is significant, right? We want to be less than alpha. That's good, okay? So then the decision is going to be to reject the null. Okay. So then what's the conclusion? Well, the conclusion here, we have to answer the question. Okay, so it says, can we conclude from our findings that more students applied elsewhere? Well, if we're rejecting the null, that means that what we were claiming has some support, has some validity to it. We have to investigate it a little bit more. Nothing's totally proven here, but there is certainly evidence to suggest it. So here's what the sentence says. It says, there is strong evidence to support the claim that more students applied elsewhere. Okay, and so again, that answers the question that was posed, right? Can we conclude that from our findings that more students applied elsewhere? And the answer is yes, we do have some evidence to support that particular claim. And again, the reason is because that p-value was less than alpha, which means it is significant. That's the good news, okay? So once again, I want to draw emphasis to a couple of things, okay? The test statistic here was 2.5, just again testing that vocabulary. P-value was 0.0062, that's the probability. Rejecting the null decision, rejecting the null hypothesis. This is sometimes called the decision, okay, the decision. And then our conclusion here is the strong evidence, actually answering the question. So I hope you guys were able to follow the hypothesis test. In the next video, we will go ahead and do it.